Hello everyone, welcome to my review of the 2024 AMC10A. As shown in the thumbnail, we want to try to cover all the 25 questions in 75 minutes, but the video is a little bit longer than 75 minutes, as you can see, because I want to just make a few important remarks before we start. So, number one. Please take note that the questions are scrambled as an anti-cheating measure. So some of you are going to be taking the paper on pen and paper, and some of you are going to be taking it on a laptop or your school's computer lab or some other digital platform. Questions are scrambled in different time zones, meaning in our Asian time zone as well as in the American time zone, and also the paper and computer ones may not be the same. So therefore, I've uploaded a copy of the problems into the description below. You can just take a look at that. In case your version of the paper is not in the same order, that's not surprising because questions are scrambled. Now, the implication of this is also that the difficulty order isn't so-called strictly increasing. This was never perfectly true, but if they are scrambling the questions, then that's even more so. Okay, so do not get stuck on a problem for too long. Perhaps if let's say that questions 11, 12, 13, 14, 15, question 15 got pushed up to question 11 just as part of the scrambling, perhaps the other 4 questions are easier than that. So do not assume they're in order. Don't get stuck on anything for too long. The second point that I want to make is that just know your target. This video is targeted at finishing all 25 questions in 75 minutes at the point from which we start. If you are aiming for some other like personal target, let's say you want a distinction, you would like to qualify for the AIME, or you just want to improve from your score last year, don't try to do all 25 questions in 75 minutes. Calculate for yourself what does 6 marks for a correct answer, 1.5 marks for a blank, and 0 marks for incorrect over 25 questions translate to in terms of your target. You can look up the past cutoffs and you will know that, let's say, do I need to actually do 15 correct answers with this many blanks, or 17 correct or 13 correct, and you adjust accordingly. Okay, and so from this point on, I will try to go through the questions in 75 minutes. Now, I have, of course, looked at these questions in 2024, but to be honest, I've not really looked at them carefully for 1 year. So this is sort of semi a live solve in the sense that I have not looked at them for 1 year, and this is how 75 minutes will look like. Question 1. What is the value of this thing here? Now, it's question 1. It's not in perfect order of difficulty, but the first few should not be too hard. So you should assume that something nice happens. And when I'm looking at these, I'm noticing that numbers are repeating. 101 is repeating, 99 is repeating. So I will write it like this: 101 times 9900 plus 101. 99 times 10100 and another 99. Now, these two cancel off because they are both 99 times 100 times 101. So you're left with 101 minus 99, which is 2. An alternative is to check the last digit. The last digit, 1 minus 9, it should be 2. So there are lots of different shortcuts that you can find. Try to look for as many shortcuts as come to mind in order to save time. Number 2. A model used to estimate the time, blah, blah, blah. Okay, so this is a very long-winded question, but I'm looking at it and I think I just will take these numbers and put them in and see what I get. So the first statement, it will take 69 minutes. If the trail is 1.5 miles long, the units are correct. And 800 feet, the feet is also the units mentioned here. So B times 800. Now the second one says, as well as if it is 1.2 miles long and ascends 1100 feet. Okay, so that means that if I just subtract these two, I get 0.3a minus 300b, which means that a is equal to 1000b. If I put that into here, a is 1000b, so this will be 1200 plus 1100, which is 2300b. So b is going to be 0.03, and a is therefore going to be 30. And so I can just now get my answer, which is 4.2 times 30 plus 4000 times 0.03. So that's option B. Take note that if you are a little bit more careless with calculations often, it should be fine to just slow down a little bit, because in reality, with no calculators, I'm fast forwarding the process a little bit. Most people would do things at a more steady rate. So I just don't want to waste your time in seeing me do long multiplication, but feel free to go a bit slower just to make sure that you don't get the question wrong because you multiplied wrongly. Remember that all the questions are worth the same number of marks. Question 3. Let n be the least prime number that can be written as the sum of 5 distinct prime numbers. What is the sum of digits of n? When I look at this, what I want to do first is just write down the first few prime numbers. Okay, so I've written 8 of them down. I want the smallest one. So whenever they ask you for the least, and this is a recurring theme in the AMC10A, you would like to do what we call the greedy approach, which is just, let's try the 5 smallest ones. So 2, 3, 5, 7, 11. What does that sum up to? It sums up to 28. Okay, so that doesn't work. And then I realized that, of course, that's not going to work, because 2 plus odd will be even. And so therefore, actually, I can't use 2. Otherwise, the total is even. That can never be prime. So let's try this instead. Now, if I add this up, that is 39. So that still doesn't work, because 39 is 3 times 13. Okay, never mind. I will just take the next biggest one. That will increase it by 4, which is now 43. 43 is most definitely prime. So therefore, the sum of digits is 7. Question 4. Another least number question. And this time, not necessarily distinct. So 2024 is supposed to be written as a lot of 2-digit numbers, but you can repeat. So I want to use as few as possible. I want to use a lot of 99s. Right? So I get to that faster. Now, we do a quick division. You do 2024 divided by 99. 99 is a bit less than 100, so I expect that it should be 20. And indeed, it is 20 remainder 44. So if it is 20 remainder 44, it means that I need at least 21. 21 times 99 would be just a little bit more. So in order to get 2024, I can just reduce one of them down. Literally, 20 times 99 and a 44 would give me 21 numbers. So that's option B. Question 5. Third one in a row of this minimum number of successive swaps. It's again a greedy approach. I just want to make it look like this. And so if I want to make it look like this, I will use the most common sense approach. It's adjacent letters, right? So I will just take A and move it to the end with 5 swaps. That took me 5 swaps. Then I'll take B and move it behind these 4. That's 4 swaps, and then so on. So there will be 3, 2, and 1 swap, taking a total of 15 swaps. 15 swaps is an option. Some of you may be very used to trying to prove things. A quick proof of why it is 15 is just that at the start and at the end, there are 6 choose 2, which is 15 pairs in the wrong order. Right, so A and B, A and C, A and D. At some point, you need to swap each pair of letters in order that it goes from, let's say, AB to BA, AC to CA. At some point, they must cross. So this confirms it must be 15. However, please do not try to prove things in the AMC. You do not really have the time. So I don't know why I'm doing it here, because I just set myself 1 hour 15 minutes. But you should not try to prove things unless you have ran out of questions to do and you're checking your answers and just want to know, is it really that easy? But this question 5, although not perfectly in order of difficulty, it should be just that easy, most likely. Question 6. Here's another one of the least possible. So the AMC, like many other competitions, the same person and same committee are involved in setting a paper. Sometimes there will be a pattern of they keep asking the same type of thing. Okay, so don't expect 2025 must be like that. But sometimes you will see that same logic that just keeps on continuing. It's a good thing for us because we are now in the mood of saying that, okay, greedy to make the sum small, it means I want to make them close together, right? So 60 is 2 squared times 3 times 5. So I just use 3, 4, 5. Okay, 3 plus 4 plus 5 is not an option. Then you realize that, oh yeah, they said positive sum. That's a bit of a hint because here it said integers. And so you remember that, okay, actually no need, right? I don't actually need to have all positive. I am allowed to have a couple of negative things. So I'm just going to try to make positive, negative, negative instead of all 3 positive. And because it's a positive sum, the thing that's positive cannot be too tiny. So for example, if I use 10, I can then have the other 2 multiply to 6. So 1 and 6. So 10 minus 1 minus 6 is 3. That already seems pretty good. And if you tried, let's say, to increase it more than 10, like to 12, you can't get better. If you try to decrease 10 down, the next you can get is 6. And you won't even be able to make it positive because this is already minus 1. So just a bit of trial and error will confirm that, yes, the best you can do is get 3 in this way. Question 7. What is the least value of n such that n factorial is a multiple of 2024? Pro tip, please know the factorization of the year as well as the one before and after it. So 2024 is 2 cubed times 11 times 23. Our current year, 2025, is 45 squared, which is also 3 to the 4 times 5 squared. 2026 is 2 times 1013. It is a pretty good idea to know all of these because the year number is often used as just random choice of number. When you know this, then the answer comes immediately because n factorial must be a multiple of this. 23 is the biggest prime number, so you know that n must be at least 23. And if n is 23, obviously the numbers 8, 11, and 23 are going to be in the list of 23 factorial because 23 factorial is just 1 times 2 times 3 and every number in between, including 8, 11, and 23. So no question that 23 works. Answer is D. Do you realize that the questions don't seem to be really in order of difficulty here? They're all just over and over again asking me for the least. So I cannot compare them. Don't be afraid to skip if something in between feels difficult. just at that moment you're not seeing it. Or if you are not sure of your answer, just put a marking either on your paper, or if let's say you are doing it on a laptop, put a marking on your rough paper just to remind yourself, I will come back and check this later. Because every question is worth the same number of marks. Checking an easy question is faster than solving a hard question. Okay, question 8. 100, you keep on doing this operation 100 times, and the operation you're doing is, if it's a multiple of 3, divide by 3, not a multiple of 3, plus 10. When I see this, I want to just experiment and see what happens. And I realize that this is what happens. Once you reach 10, it just loops 10, 20, 30, 10, 20, 30. So if it's a loop of cycle length 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the 7th, 8th, and 9th number are these, and then it loops around. So 100 divided by 3, you get 33 remainder 1. This is also going to be remainder 1 when divided by 3, and so therefore it is going to just be 30 on the 100th time. Question 9. Oops. Chocolate factory. This is some kind of a rate question. So Amy, Bomani, and Charlie, I don't need to separate them. I'm just going to collectively say that 3 of them are able to pack 4 plus 3 plus 3, which is 10 package in 3 minutes. Daria herself is 5 packages every 4 minutes. And they finished 450 packages at 2:45. Okay, so what time did Daria join? Let's just assume that Daria did nothing. From 2:45 to 1:45, it's 1 hour 45 minutes, which is 105 minutes. And 105 minutes, there would have been 350 packages by Amy, Bomani, and Charlie. So that means that Daria packed 100 packages, and 100 packages is going to take her 80 minutes. So if Daria took 80 minutes, you just go backwards by 1 hour 20 minutes, and your answer is 125. Question 10. In how many ways can 6 juniors and 6 seniors form 3 disjoint teams of 4 people such that each team has 2 juniors and 2 seniors? Okay, by the way, juniors and seniors referring to the levels in American high schools. You're going to have some of these kinds of American jargon. Don't get distracted by it. Chances are you don't need to know any American jargon. Okay, so 6 juniors and 6 seniors. I'm going to sort of view it like this. I've got 6 juniors and 6 seniors. And there are teams A, B, and C, which I'm giving temporary names. There are no names, right? I just call them A, B, C. This is important in a while, that we have to remember that these are temporary names. So there are 6 juniors and 6 seniors. I need to pick 2 and 2. Disjoint just means no overlap, which makes sense. There are 12 people and 3 teams of 4. So for my 2 juniors, pick 2, and then 2 choose 2, which is just one way, because once you have picked 2 and 2, the ones in team C are fixed. So 6 choose 2 is 15, 4 choose 2 is 6. There are 90 ways for the juniors, and another 90 ways for the seniors, which gives you 90 times 90 equals to 8100. But then you remember that, there is no such thing as team ABC. So if let's say that I now rotate around the A, B, and C, they are actually going to be the same way to distribute them into teams. Therefore, my answer should actually be this over 3 factorial, which is 1350. Okay, quick checkpoint. It's about 15 minutes for 10 questions. If you want to complete the paper, you have to do it at around this rate, 15 minutes for 10 questions. If you would like to do, let's say, 20 questions, you can probably afford up to 25 minutes on 10 questions. And if you are trying to qualify for the AIME, you can probably afford up to like 35 minutes on 10 questions. That's a rough estimate. Obviously, what comes after will affect how easy or difficult the qualification mark will be, and that will also affect how much time you should have spent on the front. But just try your best to be efficient. Okay, question 11. Adventures of Math game. This is a pretty random sounding question that looks way too easy, so I think we should be careful. It starts at 1700, and then 1780 minus 90 is 1690, minus that is 1680, plus 60 is 1740, and then after that it went back to 1700. So all of these, therefore, I'm going to just look at it as 1700 plus, there's a 0, 80 minus 10 minus 20, 40, and 0. This divided by 6, meaning that the average of this is 90 over 6 is 50. So therefore, the average is 1715. Now, what I am thinking that the trap is for this question is that some might be tempted to just combine all of these together and say that, oh, that combines to 0. And so you say that, oh, it's still 1700. Now, combining them together doesn't give you the average, it just gives you the final result. As like a bit of exaggerated example to make that clear, imagine that the scores were plus 100,000 on the first day, and then after that, minus 1, minus 1, minus 1, minus 1, and then after that, minus 99996. Now, obviously, this means that you end up on the same score as you started. However, the average will be really high because you immediately got this huge score and it stayed as a huge score until the end. So this is just an example to illustrate why you cannot just combine these to get the overall average. You combine this, it only gives you the final score. Okay, question 12. This seems to be a little bit tedious, and sometimes, if it were up to me, I would just skip this question first. Okay, I'm just going in order for this review, not to confuse anybody. So if I'm looking at this, I would just say that let's check what happens in each combination in an algebraic way rather than in a numeric kind of way or in a geometric way, because the drawing is not very accurate. So if I start at a point xy, right, this is the coordinate plane, translate 2 units to the right means increase x by 2. Rotate counterclockwise around the origin. If this is x and y, you rotate it 90 degrees to here. This is minus yx. Reflect about the x-axis is simple. That's just x negative y. Dilation just means double, so 2x, 2y. Okay, so these are the 4 types of things that you are doing. And I am just going to check all of these. And for convenience, I am going to just call these ones A, B, C, D, and then just check. So A and B, translate, and then rotate, versus rotate, and then translate. Okay, nope, so these two are not going to commute. Commute means the reverse order is the same. Okay, AC, if I do A first, and then negative, this one will work because essentially they are just unrelated to each other. One's doing X, one's doing Y. So this one works. Translation and dilation. By the way, please don't worry about making your handwriting too good in the contest, but make sure that you can read your own handwriting. So +2 like this, those are not the same. Okay, I'm going to erase all of these here so that I have got space. So far, I've got just one of them, BC. Okay, so flip them around and then reverse the sign of the first one. Nope, that doesn't work. Dilate. Okay, so this one is yes, because all you're doing is the 2 is its own factor, the switching the order is its own thing. So this works. And then CD and DC, just scaling. Yeah, so one of them is just going to be ×2, and then you flip it around, it will work. Now, there is no better way to do this, although if you want to try to draw it, maybe you can see it, but you still have to draw like a whole bunch of options. I will skip this question, and I also suspect that this is the kind of question that sometimes is put there as a time waster for people who are trying to finish the paper. If you are trying to do 15 questions, you should do this, it's not hard, but do it very slowly and very carefully. Yeah, so AC, BD, and CD are the ones that commute. Okay, 13. How many ordered pairs of integers mn satisfy this equation here? This is a classic if you are watching from Singapore and we have done the SMO, we see this a lot. Just square both sides, difference of squares, factorization, and what you should bear in mind is that m cannot be negative, but n can be negative. So m cannot be negative means that n plus m is the larger one, but it is also perfectly possible to be -7 -7 or -1 -49. So each of these you can just check. It will give you a valid option because all we need to make sure is that m cannot be negative, and all of these would make that true. So the answer is there are 4 pairs. If you want to check your answer, of course, you could find what n and m are, but if you just want to count how many, technically that is not necessary. Okay, 14. All of the rectangles in the figure below, which is drawn to scale, are similar to the enclosing rectangle. Okay, so all of them are similar, meaning that we can say that I just need to find the scale. So let's make the small one, let's make the ratio x is to y, where xy is equal to 1. Now what I want to do is essentially to just use the big rectangle to get some information on what is x and y. If I were to look at these here, 36 is 6 squared, meaning that this is actually 6y. And this is actually 7y. Now 18, square root of 18 times of x here, and square root of 32 times of x. So what's my conclusion? My conclusion is when I compare these two, y equals to square root 2x. Okay, so now I don't actually need to do too much. I'm just going to look at the equation here that says xy equals to 1. So square root 2x squared equals to 1. X equals to 1 over the fourth root of 2. Honestly speaking, in context, I'm already going to say this because there's no more squaring. All I'm doing is going to be adding up lengths. There must be a fourth root. So that's the only way it can happen. If you wanted to check, this is 4 root 2y, this is 5x, this is 7x, and you could just substitute in 4 root 2y plus 12x and confirm that this is really correct. Because y is root 2x, meaning that this is actually 8x. So yeah, you can confirm the answer. Very often use the multiple choice options to speed up. If you can tell that there's only one answer that looks even vaguely like what I found, 95% chance that it is going to be correct. So if you are running short of time, just make the guess. Okay. Question 15. It does not look like question 15 has a particularly convenient way of being drawn to scale with the tools we have. But it's an equilateral triangle and a circle, so I think just draw as best as we can. So there is a line L. There is an equilateral triangle with height 24. A circle radius 12 is tangent to L and is externally tangent to the triangle. So there is a circle somewhere here. I am drawing the one feature that I know, which is actually that they're supposed to be the same height because the radius is 12. So that's all the information I get, and the question is asking what is the area bounded by the triangle, circle, and line, which is this portion down here. Now, what I can see is that there are a lot of things that should be nice. As you can see, I'm not worrying about drawing a perfect diagram. Don't take the time to do that. Just draw a decent diagram. I think that what I'll do is just find this portion here. This is going to be subtracting off then the sector, which would give me this. Okay. Now, essentially, in this diagram, what I can say is that pretty much everything is going to be a 30, 60, 90 triangle. Right? It's an equilateral triangle. This is 60 degrees. So this is 120 and this is also 60 degrees. If you were to try to find the sector, therefore, the sector is 1/6 times pi times 12 squared, which is equal to 24 pi. That's the sector. Now, as for what is the area of this portion here, we just remember that if this is 12, by symmetry, if I chop it up, This will also be 30, 60, 90. And 30, 60, 90 triangles, the ratios are 1 is to square root 3 is to 2. So this is 12 over square root 3, which is 4 root 3. Your area here is half times 12 times 4 root 3, but 2 triangles, so it's back to 12 times 4 root 3. 48 square root 3 minus 24 pi is going to be our area, and then 48 plus 3 plus 24 is how the answer is extracted. Now, we are at 15 questions. So time track now is about 30 minutes in. This is also a reasonable target, which is that if you want to do the whole paper, 15 questions in about 30 minutes is good. The cutoff for the AIME last year for the 10A on this paper is 94.5, which means that if you had done 15 questions like this, you would get 105, which in fact is already the cutoff for a distinction. In a way, that means that you actually have to only do 15 questions to get the distinction for last year. Of course, it's not a guarantee. Sometimes you need 1 or 2 more. You have up to 75 minutes if you wanted to. I've taken 30 minutes, so we're making good time, and it is really not as big a rush if that is your target. You can literally be taking twice my amount of time and you're still fine. Okay, question 16. This is deja vu because difference of squares part 2. These are both perfect squares. I can take the difference and therefore a difference of squares equals to this. I want the greatest integer, and so if I want the greatest integer means I want x and y to both be big. If I want x and y to be big, it means that I should not worry about factorizing this. I should just make x and y big and the difference small, right? So 2 big ones. So if I put this, however, you will see that y plus x and y minus x, if you add them, you get 2y is 2561, which is not an integer. So actually, this would be the next one, which will ensure that it works because y will be 641 and x would be 639. The question is kind of nice. They just asked for the units digit, so last digit would just be 1 squared minus 3, which is going to be 8. When they ask you for things like the last digit, or in here they ask you for a plus b plus c, this is what is known as answer extraction. So for answer extraction, you don't need to think of the significance of the units digit too much. Just solve the question and thereafter just get the answer because it's multiple choice. They are not going to ask you to just say which is m, because then you'll be able to test them one by one. They won't ask you which is the area because it's quite easy to guess. So this is sort of an anti-guessing measure, but it also means you save time on actually calculating what is m. Okay, 17. And this is base representation. The American contest like bases, so do check it out if you're not familiar with what bases mean. I'll just give you the definition here in one example, which is that when we have the base b integer like this, it means that the place values instead of base 10 powers of 10 are powers of b. So 2024 in base b is just 2b cubed plus 0b squared plus 2b plus 4. I want this to be divisible by 16. If I then divide this by 2, this must be divisible by 8. Now, at this point, you can just check b congruent to 0 to 7 mod 8 and see which ones work. A tiny shortcut is just that if b is even, then b cubed is divisible by 8. So you need b plus 2 to be divisible by 8, meaning b is 6 mod A. If B is odd, then you can kind of just check it manually, I guess. Alternatively, when B is odd, we know that B squared is congruent to 1. So B cubed is congruent to B. And therefore you need 2B plus 2 to be divisible by 8. And this would give you B is 3 or 7. Just giving a shortcut here, but in reality, you can very easily just check 0 to 7. It doesn't take too long. So now 2024, we know it's a multiple of 8. So when I go from the numbers 1 to 2024, and I want 3 possible remainders, K is going to just be 3 times of this because there are 3 values in every cycle of 8. But I don't want to include 3 because 3 is not included here. And the digit 4, by the way, you're not allowed to have a bigger digit than the base. So when it is base B, your digits are at most B minus 1. So this is reinforcing that. B is 3 itself is excluded. So 758, and the digit sum is 20. Question 18. Geometric sequence. Geometric sequence, definition of this is just a common ratio. So 720 over A equals to B over 720. In other words, you're just multiplying the same thing every time, not necessarily a whole number. Now what I want is the least possible value of B where A and B are both integers and AB is just 720 squared. In other words, because A is less than 720 less than B, I want B to be a little bit more than 720. And so if I want a little bit more than 720, I can just adjust it by factoring 720 first. The square is this, and then I will look for the least possible value by kind of just making initial guesses. So how close can I get to 720? The powers of 2 go up to 256, and I can see that 256 times 3 is 768 is pretty good. Once again, this is the AMC. It is a little bit tedious to actually go and write down all the factors and check, but I can tell you that this is actually the smallest we can have. Okay. Question 19. A best of 3 match, and the first to win 2 will win. There are 2 teams, A and B, and the first game is played at A, the other 2 games are played at B, right? So the location will affect the probability. So game 1, I'm told that team A has a 2/3 chance of winning, so B has a 1/3 chance. And then games 2 and 3, probability is just P and then 1 minus P. I'm told that the chance that A wins is half. So the chance that A wins is half. A wins if they win 2 out of 3 games, which is either they won the first two, won the first and third, or won the second and third. So these are the three situations where A would win. I'm just going to calculate the probabilities of each one. A wins the first two is 2/3 P. A wins the first, loses the second, but wins the third. B wins the first, but A wins the other two. This is just a quadratic. Nothing to be afraid of in a quadratic, especially because I see that it mentions half m minus square root n. So it does look like you do have something of that sort. So you will end up with 1/2 equals to 2/3 p plus 1/3 p squared, which will rearrange when you multiply by 6. Wait, that doesn't look right. It's supposed to be minus 1/3. So if you multiply by 6, you're going to get 2p squared minus, oh, sorry, this is 4. And then we just use the quadratic formula. Since it's written in this form, I don't want to even try to factorize it. Since I know that it's supposed to be minus, I can just say that this is 2 minus, but oh, it's actually asked in this form 1/2 m minus root n. So I guess just cancel. And then you will have 4 and 10 as your m and n. Now, I'm doing this in one take. As you can tell, as we go along, we will start to fumble a bit more. This is the nature of like concentrating non-stop. So if by now you're saying that, oh my gosh, my brain is hurting, that's right, your brain should be hurting. When you're doing an AMC, 75 minutes is not a lot of time. You should be trying to keep up quite continuously. It should feel tiring. If you don't feel tired, you're not doing things right. Okay, question 20. This is a kite, squiggly K is the kite. You use 8 copies of this, and my gosh, this is very hard to actually read. I don't really think that I can even see where the kites are. And I think that's because, honestly speaking, by drawing in the triangle ABC, they are distracting me more. So I'm going to just take away that triangle for the time being. And sometimes, of course, you can't really do this, but just imagine taking it away, all right? So imagine taking it away. So this is actually what is going on here right now. You have you can hopefully see the kites a bit better. There's also this line AB that is a little bit of like a blockade. Now when I am looking for what's going on, that means that actually I just need the base and the height. I don't need to draw the whole triangle. I just need to know what is this distance and what is this distance, and then it is half times base times height. Okay, so the good news is that I know all of these are again 30, 60, 90 triangles. So if this here is square root 3, then this is square root 3 over 2 times square root 3, right? The ratio is square root 3 is to 2, is 3/4, and I've got 4 of that to make AB. So this is just 3. Next, I want the height. The height is also easy because this part is literally square root 3, and this part is just half square root 3. So this is 1.5 or 3 over 2 square root 3. I realized that I again have written something wrong. This is 3 over 2, right? And this is 6. Yeah, so that's when I'm looking at the options. The good thing is that the options kind of tell you that, hey, wait, you have done something wrong. It's none of the above. And then quickly, just go and check your steps. Most likely you've written something down that is just a little bit silly because you're in a huge rush. Okay, so area is half times 6 times 3 over 2 square root 3 is equal to 9 over 2 square root 3. There we go. Okay, time check. 20 questions, about 45 minutes in. This is still about the correct pace if you want to finish the paper. However, if you have reached 20 questions with like 15 minutes left, you're doing pretty well because you only need to do one more question to get the honor roll. One of the last 5 is enough. So again, if you want to get a DHR, for last year the cutoff was 132, that would be 21 correct questions and 4 blanks. We are at 20 questions in 45 minutes, so still good. 21, the latest iteration of maximum possible. Now let S be a subset of 1 to 2024. When you see this and it says maximum possible, it just means please pick as many as you can. Now pick as many as you can such that all of them, the difference is more than 2, right? So that means that the difference is at least 3, and the difference of odd numbers is at least 7, okay? Of course, the difference of odd numbers is at least 7. It can't be 7, so the difference is at least 8 of odd numbers. As before, I am just going to try a greedy approach. I'm going to just pick starting from the number 1. Why should I skip number 1? I don't know, so let's pick 1. The next number must be at least 3 away, so that can be 4. The next number must be at least 3 away, but it cannot be 7 because 1 and 7 are too close, so let's pick 8. The next number can be at least 3 away, so that's 11. Then at least 3 away, and then it can't be 17 because 11 and 17 are too close, so we pick 18. And I realized that, oh, this is a very silly pattern. This is just the last digit are 1, 4, and 8, and that repeats. That can't be too bad. So it's just 3 out of 10 from the first 2020 plus 2 more is 608. I'm circling it just like I mentioned earlier. In the AMC conditions, I'm probably not going to think of a proof. But if you are trying to look for a proof, very easy, just look at any 10 numbers in a row. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How can we pick more than 3 out of 10 numbers? If we want to pick more than 3 out of 10 numbers, and every block of 3 you can pick at most 1, then the only way you can fit in is this, but then that will violate the second one. So it means that at most 3 out of 10, which will already confirm our answer, right? Because at most 3 out of 10 means that at most 606, and then at most 2 from the last 4. So in fact, we have double confirmed this, but I would say don't worry about proving or double confirming in limited time. Okay, 22. The numbers in order of each row and the numbers in order of each column of a 5 by 5 array of integers form an arithmetic progression. Okay, so just now we had the geometric sequence, common ratio, and now we have the arithmetic progression, which means a common difference. I don't really need to read the words because it's in the array, the grid here. What I am thinking is that this should not be so hard. to solve almost like a Sudoku. This should not be too hard to solve almost like a Sudoku, meaning that I just will try to fill in the numbers one at a time, but I do have at least one unknown that I should set up. And I'm not going to set up this one because it's not so friendly. In fact, I am going to set up the rightmost column because this is 0. I'm just going to let this be x, 2x, 3x, and 4x. X could be negative, by the way. I'm not insisting that it's positive. I just like this because now what do I do? Now I can just try to solve for x in some way by looking at the common difference in each row. Okay, so I want the least amount of algebra. So I'm just going to say that, okay, this difference here will be the same as this difference here. So that is going to be another 16 minus x, or 32 minus x. This difference is going to happen 3 more times. So 48 will go to 192. And then minus 3x 3 more times, so minus 9x. And this must also be an arithmetic progression. Which, if I solve this, I just get a very healthy x equals to 20. So great. X equals to 20 means that very anticlimactically, this is just a whole column of 12s. This is 80. And so if this difference here is 68, this difference is going to be 68 over 4, which is 17. And then 12 plus 17 is equal to 29. For a problem like this, you may say, how do I know I'm supposed to use that column? And the answer is you don't have to. I just pick the most convenient one because I see a 0 there and that felt nice. If you wanted to, let's say, fill the bottom row, absolutely fine. If you wanted to just let this number be x, I would say that is not enough for us to write any other number. So you should write something else. If you wanted to, let's say, call this thing x, sure. If you wanted to go and call this thing x, sure. There are many options. I just picked the right column just on a whim because working from 0 looks nice, right? When we're doing a speed contest, you would like to minimize the amount of algebra you need to do. Also, these are not that hard, right? I mean, I'm looking at it now and I don't really feel that these last 2 questions we've done are impossible. Remember the thing about shuffling the questions, right? It is possible that not everyone received this as the final 5. It may not be that hard. It may turn out that this year they make the final 5 very hard. We cannot say for sure. But you should, if you are stuck, take some time to look at everything, even all the way to the end. Don't assume that the ones behind are too hard for me. Okay, question 23. I am looking at this AB plus BC plus CA, and I feel tempted to add them all up. There's nothing wrong with adding them all up, but there's no way that I can make A plus B plus C just disappear. Then I realized it says integers. Please read things like integers versus real numbers versus positive versus non-negative carefully, because it not just is avoiding careless mistakes, it tells you what kind of approach to take. When you say integers, it means that you are going to be willing to just make a factorization show up. Even if the other side is not 0, you can solve. So I will just take these 2 equations and just subtract this from the other. And by grouping, I'm able to factorize immediately this thing here. 13 is a prime number, and if you try the other combinations, let's say 100 minus 60 is 40, that's more. 13 gives you less cases to check. It's just 13 and 1, 1 and 13, or vice versa. Okay, so I can just put each of the values of b into the first equation back again to see what it tells me. I get 13a plus c is 100, a minus, I can just fast forward it, right? Because if I were to now just take each of these, I can just fill it as a table. So plus 1. Now a minus c, I can eliminate c all at the same time, right? Just add the two things here. So this plus this will give me ab plus a is 101, 113, 99, and 87. So b plus 1 had better be a factor of this. The first one doesn't work. The second one doesn't work. The third one gives me a is -9. And the fourth one gives me a is 87. Okay, how do I check which one is correct? I can go and just put it into another one to just see what is C. So I put it into, let's say, the second one. Minus 12C minus 9 is 87. Would give me C is -8. Whereas this one would just, I need to put in the third one. B is 0, CA is 60, that doesn't work. So we have -9, -8, and -12 as our three values, and we just substitute those in. Again, this is an answer extraction. This is not really asking you to find AB plus BC plus CA specially. Okay, so the numerical answer when you add this up is 276. #24. A bee is moving in three-dimensional space, 6 sides like this, and basically the question is saying that your A, B, and C plus and minus correspond to these three things being plus or minus 1. Now, some unit cube. Unit cube is a 1 by 1 by 1 cube. So it means that what's the chance that the bee's movement is going to be something that falls within a cube? Whenever I have any such question, I don't want to keep rotating my head, but I do know that there's a lot of symmetry. So I don't want to branch too much because that requires more rotating my head. I will say that, firstly, the first move does not matter. So irrelevant. Now, the second move, essentially, if I go further out, I fail. That's not going to be part of a unit cube. If I go backwards, that fails because they're not distinct. If I go in any of the remaining 4 directions, by symmetry, they're all the same, right? Left, right, up, down, they all are this L shape. So 4 out of 6 ways that are still acceptable and they're all the same. So let's draw this one and continue. All right, now the third one. And the fourth one, I guess, should be handled together because I no longer have symmetry. So this one doesn't work, this one doesn't work, this one doesn't work. I've basically now got up, down, or back. So the first case is this. So move 3 and 4. There is a 1/6 chance I come here. And if I come here, this direction is okay. This direction is okay. This direction is okay. So 3 out of 6 directions are okay in terms of it being part of a unit cube. If I went up like this, then I've only got 2 options, either this way or back across this way. And same if I went down, because that's just symmetric. So two other options, this one or this one, would give me 2 out of 6 options on the final one. Okay, and I just combine these together. So I left it unsimplified to just show you that everything is just, I'm counting how many of the 6 work. This is not nearly as complicated as one might fear, because of all the symmetry of that. The first move doesn't matter, the second move almost doesn't matter. So therefore, not so bad. Okay, this would simplify to 7 over 54. Okay, great. So we are actually ahead of time, right? We have only just used slightly over an hour. And this is precisely why for the AMC, some people would be able to finish. But of course, I am sort of doing a little bit of expediting in terms of the calculations. You could add 10 more minutes to your calculation time, most likely, because, well, I do have a copy of the answers just to make sure I don't say anything wrong. So the numerical answers are there as a check for me. You might need to spend a bit more time checking. Okay, final question 25. This is a pretty nice question. Because it says, place some toothpicks along some of the sides to create a loop that does not intersect itself. The numbers indicate how many sides are to be covered by toothpicks. And any number are allowed if no number is written. This is an example of a slider link puzzle. I like puzzles very much, so I find it familiar. But this is also not exactly like slider link, because the question is how many ways, whereas in the case of the logic puzzle, there should only be one solution. But it's inspired from there for sure. Whenever we are asked to find how many ways, and you are not sure how to do it, my advice is that you should just try to do it in one way, just to get a sense of what's going on. So let's say if I say that, okay, I'm going to just try to do this randomly, right? So I'm just going to start drawing like this. Then I say that, okay, so I cannot go through here anymore. Let's say I go here. Now, if I go across like that, I'm stuck, because I need to go back and then I need to go around. So like maybe if, and I can't go up, so I said, okay, maybe I will just do something random like this. And then only at the end, then I can go up, because I don't want to segregate it into left and right. I come up and I say that, okay, this guy still needs one more, this guy still needs one more. So in a way, it's like, oh, I can make that happen. So, okay, one random example that works. Now you realize that, oh yeah, this is actually a reasonable approach. It's a reasonable approach because if I do this, you're going to end up with just some of them are above, some of them are below, and I have quite a lot of ways to choose. That's why the choices are in the hundreds. Let's now try to sharpen our understanding a little bit in terms of what do I actually get to choose. Right, so when you ask how many ways, I find one interesting way, and then that gives me some understanding of like what sort of restriction is there really. Okay, now I was talking a lot about crossing, right? So if let's say that you do this, if this edge is there, then you are forced to go like this, and immediately you fail, because I can either only go this way or the other way, but I can't satisfy both. So in reality, I cannot really use the edges between the two. I sort of said, all right, I can't use that. And likewise, none of these are actually proper crossings. Except I am allowed to use something like this, because that doesn't partition anything. So I do need to cross somewhere. And as it turns out, it looks like I can only cross at the boundaries. it also doesn't make too much of a difference, because if let's say that I cross here, now I'm just doing some stuff down here. If I cross here, then I continue here, and then I'm still doing some stuff here. So it is pretty similar. I will just do a little bit of now checking, because I do know that there is the left and the right. So maybe if it depends on how I go on the left and how I go on the right. So if I pick the two boundaries like this, meaning that I then continue like this. If I pick the two boundaries, then for the remaining 6 squares, I basically am just saying that some of them I will pick the ones on top, some of them I'll pick the ones below, and then that will determine the path. So there are going to be 2 to the power of 6 choices. If I were to go and do the crossing down here, the logic's the same except that I'm only left with 5. And if I were to do the same on the other side, it's also going to be that, yes, if I have this, I only get to pick 5 of them, whether I use the above or the below edge to put a toothpick. Now finally, if let's say I use this, then only 4 get to be picked. So it's 2 to the 6, 2 to the 5, 2 to the 5, 2 to the 4 equals to 144. Except that if you were to look at this and you were to look at the options. Now this is one final tip. Look at the options and you will say, hey, there's one like that. When you see the nearby option, like just +1, +2, -1, -2, or like 2 times of it or half of it, especially for counting questions, just take a moment to be suspicious and say, have I forgotten anything? Like, is there any other situation apart from I come up here and I come down here? And the answer is yes. There is also the option to not come down at all. So if I don't ever cross through that middle portion, that must be either doing this or doing that. So that's +2. Okay, so this is my solution. +2 more equals to 146. Okay, so it turns out that I've taken actually less than the 75 minutes. As for any of these questions that I've done the calculations a bit more quickly, feel free to ask. But I want to emphasize on the speed of thought. Basically, in the AMC, we are lurching from question to question, and we need to be able to very quickly switch between totally different questions, a lot more quickly than even the SMO. So do get some practice in. The past papers for the AMCs can all be found, some on my YouTube here and some also just on various platforms. Take a look at the past papers, try them so that you get used to thinking very quickly for 75 minutes. Because in this whole paper, I think the number of formulas or theorems that I've said are actually very few. If you realize that, I've not used a lot of special things you have not heard of. It is just about being able to quickly reason and notice things. This is the American style for the AMC10. Okay, so I hope this helps. Thanks for watching. And you can also look at the AMC12A video a little bit later on. The AMC12A has quite a lot of overlapping questions with the AMC10A. Same with the 10B and 12B. So there will be some overlaps along with some harder questions. Feel free to take a look at that as well.